First, I started by initializing a new project using npm init, which set up the package.json file for my frontend app. Then I installed Tailwind CSS using npm install d-tailwinds and configured it by creating the tailwind.config.js file. I also added Tailwind's base, components, and utilities in the main CSS file. After setting up Tailwind, I created the initial structure of the web page using simple HTML and styled it using Tailwind classes. This included a header, an input field for the city name, and a button to trigger the search. I designed a responsive card layout where the weather information will be displayed. This card shows temperature, weather conditions, humidity, pressure, wind speed, and visibility. If a spelling mistake, it displays the error, could not find. I use this icon URL to update the weather image in my app. The image changes automatically when the user searches for a new city. This helps users instantly understand the weather visually. It's a small but powerful touch to improve user experience. Then I used the OpenWeather API to fetch real-time weather data. First, I used the geocoding API to convert the city name to latitude and longitude. Then, using those coordinates, I fetched the current weather using the Weather API. To test the API calls and see the full JSON response, I used console.log to explore and understand the structure of the data before using it in the UI. For deep testing of API, I console each const separately. Here you see the data fetched and displayed in the console. I logged the Geo API URL to verify the city name was correctly inserted. This helps ensure the location fetch starts properly. And I checked the response of the Geo API to confirm it returned lat/lon. I log the data to verify the city exists and the coordinates are valid. Next, I built and logged the main Weather API URL.weather URL. This tells me if the coordinates were correctly passed. Here you see the large list of hourly weather and humidity. Now, check that the responsiveness is good for every device. Now I will display the actual code, simple UI design, and script file where we have an API and fetch the URL, then console the data in JSON. I created a function to update the UI dynamically with the API response. It shows the weather icon, temperature, and other conditions in real time after the user enters a city. Then I added 3 interactive tabs: hourly forecast, humidity levels, and air pollution data. Each tab fetches and displays relevant data using the OneCall and air pollution APIs. The hourly forecast displays upcoming temperatures and conditions for the next few hours. The humidity tab shows hourly humidity levels, and the air quality tab lists PM 2.5, PM 10, CO, and NO2 levels. Finally, I cleaned up the UI, added error handling for invalid cities, and made sure the app was mobile-friendly and smooth to use. This was a great project to learn APIs, Tailwind CSS, and real-time data handling. I hope you like it.